Hi everybody, you are welcome to this channel. I am Otanu Betal, and like every lecture sessions, in this lecture session we discuss about a topic. It is how to balance a redox reaction by ion electron method. This is in two medium, generally happens in two medium. One is acidic medium, another is in basic medium. In this video lecture we discuss more about the point that redox reaction balancing by ion electron method. This is our topic, in which we make a clear discussion that ion electron method for balancing a redox reaction. Okay, so before discussing the full topic and the full process of ion electron method, we understand this topic with an example, and the full process I like to discuss about the full details about ion electron method in this lecture. So before making more deep discussions, we need to understand some points. Okay, what is oxidation, what is reduction, and uh, what are called half reactions. Okay, oxidation reduction means the reaction where loss of electron and gain of electron takes place, or in oxidation reaction you can say loss of electron takes place, and reduction reaction gain of electron takes place by an atom ion. And in terms of oxidation number theory, you can define oxidation means increase of oxidation number, and reduction means decrease of oxidation number. Okay, so you can find the a detailed discussion about what do we mean by oxidation and what is mean by reduction, oxidizing agent and reducing agent. You can see my other videos that are already uploaded to this channel. You can go strictly to playlist, where you can select the redox reaction playlist, and after that you can watch all these related video to oxidation, reduction, oxidizing agent and reducing agent. Okay, now the important point is what are the methods for balancing a redox reaction. To balance a redox reaction, there are two methods. One method is oxidation number method, another method is ion electron method. There are two methods, and today we discuss about one method, that is ion electron method. It is our discussions of today. And for balancing a redox reactions, there are two methods. Okay, the first method is oxidation number method. First method is oxidation number method, or you can say anyone as first, second, and the second method is the ion electron method. And both method can be practiced in or given, both methods can be given in acidic on and either acidic or in basic medium or in both medium. Okay, we have to balance the oxidation redox reaction in acidic and basic medium by these two methods. One method is oxidation number method, another method is the ion electron method. These two methods of balancing redox reactions are generally performed in acidic medium as well as in basic medium. So today our discussion is about the ion electron method in acidic medium. We balance the redox reaction in acidic medium. Okay, so before going to balance the redox reaction, we try to understand some common points of balancing. We know that a redox reaction contains two halves. Two half means one is oxidation half, another is reduction half. Oxidation half generally loses electron and reduction half gains electron. So for balancing a redox reaction, first we have to find that which half is getting oxidized and which half is getting reduced. After finding these two half, we have to balance these two half, means we have to balance all the atoms that are present in the left hand and in the right hand side. After atom balance, we have to balance the charge, and after charge balance, we add these two equations, and after adding the two equations, oxidation equation and reduction equation, the full equation that we get after adding these two equations will call as redox, balanced redox reaction. Okay, so the process is very simple, and for balancing steps, if we want to balance the oxidation if we want to balance oxygen in any side of the equation, means oxidation equation or in reduction equation, if we want to balance the oxygen atom in any side, left hand side or right hand side of the equation, then we have to add water molecules to balance oxygen, and to balance hydrogen atom we have to add H plus ion. If the reaction is taking place in acidic medium, then we have to add H plus ion to balance the deficiency of hydrogen in either of the sides, in left hand or right hand. Okay, but if the balancing is done in the basic medium, then we can add the H2O molecule for removing the deficiency of hydrogen, and in the opposite side equal number of OH minus is added to solve this deficiency of hydrogen. Okay, so these are the 2 points that we keep in mind, that for acidic medium and basic medium, our hydrogen balancing is performed in a different way, but the oxygen balancing is common for all these two processes of balancing, means acidic medium and basic medium. For oxygen deficiency, H2O is added. So these are some common steps that we need to follow to during the balance equation made by the ion-electron method in acidic medium. Now we strictly go to an example where we see the details procedure of ion-electron method, how we balance a redox reaction by ion-electron method. We see this point in details. Okay, and you can find all these related types of videos like ion-electron method balancing in basic medium to the playlist redox reaction. Now strictly without wasting time, we strictly go to an example. Suppose we have to balance a redox reaction, it is SO2 and K2Cr2O7 plus our third substance is H2SO4, and 3 substances reacting together form K2SO4 Cr2SO4 whole 3 and H2O. Okay, these are the substances that are forming after the end of reaction. So this is a redox reaction, and we have to balance this redox reaction using oxidation reduction we have to balance this redox reaction using ion-electron method. So in this time we see the steps that are required for balancing this redox reaction. So first first we have to understand that this is the main equation which is given to you, that balance this equation in acidic medium. This equation is given to you for balancing and in acidic medium. So what do you need to take the first step? Your first step, what will be your first step? Your first step is splitting the ions splitting in ions. So we first split into ions. First we split into ion this equation, and if we split into ion, you know SO2 is a molecule, we cannot split it, but potassium dichromate is splitted as potassium plus and Cr2O7 2 minus. H2SO4 is splitted as H plus and SO4 2 minus. Okay, so reactants are splitted up, and after splitting in ionic form, potassium is K plus, sulfate is 2 minus, chromium is 3 plus, and sulfate is SO4 2 minus, and water molecule. Okay, so this is the splitting into ions or ionic form. Ionic form, we representing this equation, this full equation in ionic form. Okay, this is the first step for any kind of balancing in redox process. You have to do this thing, you have to split up all the ions that are all the ionic form of the compounds that are involved in the in both sides of the reactions. So we split up the ions and ionic form, that SO2 is SO2 plus K plus chromium plus H2SO4 is splitted as H plus and SO4 2 minus. So all all components that are present in the reactants and product side are splitted into ions. This is a very important step, and after taking this step, next step is eliminating the common ion in the both sides. Well, we are seeing that the common ion here is potassium ion, and this one is potassium ion. So we eliminate this ion from the both side. Okay, common ion should be eliminated from the both side. So potassium ion is eliminated from the both side. Now our next eliminating substance, here H plus is present because the reaction is taking place in acidic medium, and we cannot eliminate sulfate, because sulfate cannot be eliminated because sulfur dioxide is oxidized to sulfate. So therefore sulfate cannot be eliminated, but it is present in both sides of the equation. Okay, it cannot be eliminated. So our net ionic equation, right now we get our net ionic equation. And what is this net ionic equation? Now our net ionic equation, that we get SO2 to Cr2O7 2 minus plus H plus. You can ignore this sulfate from both sides, just keep the chromium sulfate here. Okay, so then the reaction will be like sulfur dioxide, potassium dichromate, H plus, 2 chromium 3 plus, sulfate and water. This equation is our equation after splitting all the common ions that are not changing the oxidation number. Okay, generally not common ions. Here common ions is the simple factor, but the main important thing is where the oxidation number is not changed, that species will be removed from this equation. Okay, oxidation does not change. Here we remove sulfate ion, because this sulfate ion is here sulfate means they are common. So in sulfuric acid medium reaction is occurring, therefore we eliminating these two species. Okay, so our main equation is right now becoming after eliminating, ignoring whatever you can say, ignoring all the terms that does not change in their oxidation numbers, or species that does not change their oxidation number, we get this equation. This equation is in ionic form, and we have to find out the oxidation number when on each part of the on each atom where the oxidation number is getting changed. Here we see oxidation number of sulfur is 4 plus, here oxidation number of chromium is 6 plus, here it is 3 plus, and here it is 6 plus. Okay, so yeah, and if you have any problem for calculating the oxidation number of an atom in a molecule or in a compound, then you must watch the oxidation number calculating video. And I discussed in a particular lecture about how to calculate the oxidation number of an atom in a molecule. I discussed it in full details, so watch this video from the watch list. And right now we focus on this equation balancing. This equation is see the change of oxidation number. By seeing the change of oxidation number, we can easily understand that which species is getting oxidized and which is reduced. The 4 plus oxidation state is changed into 6 plus oxidation state, so there is a increase of 2 unit oxidation number, so therefore it is called oxidation half. 2 unit increase of the oxidation number from 4 plus to 6 plus, causing a oxidation half, which is 2 unit increase of oxidation number, where 2 unit increase of oxidation number is taking place. And right in this part, the chromium is changing 6 plus oxidation state to the 3 plus oxidation state. Here net 3 unit decrease of oxidation number takes place, therefore it is called the reducing half. It is called reducing half or the reduction half. So we find two halves that are present in the whole equation. When two halves are added together, this whole equation is formed. So these two halves are already find out right now. So we have to write these two half equations separately. Okay, so we are writing the oxidation at first. Where in case of the oxidation half, you see here oxidation half is SO2 to change in SO4 2 minus. This is our oxidation half. We write it the oxidation half first, and after writing this oxidation half SO2 to SO4 2 minus, we write our reduction half. This one, is our reduction half, where reduction is taking place. 6 plus oxidation state reduces to 3 plus oxidation state, and this one is oxidation half. Already we selected the oxidation and reduction half. This is called oxidation half. This is the oxidation half, and this is reduction half. So right now our next step is balance this atom balance of the oxidation half and reduction half. Right now we see that chromium is present 2 atoms in the left hand side, so we make it 2 because number of chromium is 2, therefore we make it 2. Now the number of oxygen atom, look at the number of oxygen atom here. The number of oxygen atoms are 7, but here no oxygen atom are present, so therefore we have to add 7 water molecules to increase to balance the number of oxygen atom 7. So we add 7 H2O here. but right now the problem is that the 7 into 2 14 H plus is in the right hand side, but here no H plus is present, and for this reason we have to add the 14 H plus. The reaction is taking in acidic medium, so we have no problem to add H plus. So 7 into 2 14 H plus is added in the left hand side to balance the number of hydrogen atom in both the sides. Okay, so in this way we balance atom balance in this reduction half is completed. So right now the oxygen is 7 and hydrogen is 14 and chromium is 2. Now we have to balance this equation. Here number of sulfur is 1, but number of oxygen is 2. Here the number of oxygen is 4. So therefore we have to add two molecules of water here. So the number of oxygen atom is becoming 2 plus 2 4, but the number of hydrogen is not present in the right hand side, so therefore we have to add 4 H plus in the right hand side, because 2 into 2 4 H plus in the right hand side. So these two equation is atom balance is completed in these two equations. Okay, reduction equation and oxidation equation, in both the cases the atom balance is completed. Okay, so after atom balance, the next process is charge balance. And for charge balance we have to see that the charge that is present in chromium in both sides, it is 6 plus and it is 3 plus. So we can do one thing, we can add electron to reduce the 6 plus charge into 3 plus charge. Okay, or no, this one will be the simple thing. Okay, so in the charge balance process we are adding the 3 electron to the left hand side in order to decrease the oxidation number of chromium 6 plus to 3 plus. Okay, but here 2 chromiums are present, so we have to add 6 electron here. Okay, we have to add 6 electron here because 2 electrons are present in chromium, so sorry, 2 atoms of chromium are present here, so each chromium need to add 3 more electron to reduce in 3 plus form. Okay, so 6 electron is given to balance charge in both the side of the reduction reaction. And for this reaction we are seeing the change in oxidation number is from 4 plus to 6 plus. So one atom is present, 1 so 6 plus can be reduced to 4 plus if we add 2 electrons with it. By adding 2 electrons with the SO4 2 minus, the 6 plus is returning back to 4 plus. Okay, so this one is the charge balance step. Okay, you can clearly see it that in these two half we balance the charged of the oxidized and reduced species. Charged is now balanced, atom balance completed, charge balance completed. Then our process is we have to add these two equations. See, this equation is number 1 equation and this equation is number 2 equation, and we have to add these two equations, 1 number equation and 2 number equation. After adding these two equations, the net equation that we obtain after adding these two equations will be our main balance equation. Okay, so before adding these two equations, the one of the most important point is that the electron gain by the reduction process must be equal to electron lost in the oxidation process. In the oxidation process, oxidation half, 2 electron is lost or 2 electron is produced, but in the reduction process 6 electron is used, 6 electrons is gained by the species in order to change to lower oxidation state. Okay, so for this reason the electron number that we see in both the equation should be equal, and to make equal electron number in both the equations, what we have to do, okay, 6 electron what we have to do here, this we are saying that here it is 6 electron and it is 2 electron, so therefore we have to equal this 2 electrons number. Okay, for making equal of this 2 electron number, what to do, we multiply this equation using 3. Okay, and this equation does not need to change anything in this equation, multiply anything in this equation, because by multiplying 3 in this equation, the electron number will become 6. Okay, then we add these two equation. Okay, after equating the number of electrons in both the equation equal, so if we multiply this reaction, full reaction, if full reaction we multiply with the full reaction using 3, then we write the equation here 3 SO2 and 3 into 2, here it will become 6, and here it will become 3, and here it will become uh, 12 H plus, and here it is becoming 6 electron. Okay, so now this one is 1 number equation and this one is 2 number equation, and we add these two equations. 1 and 2 equations are added together. So by adding these two equations, what do you obtain? Chromium dichromate ion plus 14H plus, and plus, we are not writing the electron number because this electron is present in the left side and this electron is present at the right side of the equation, so automatically get cancelled. Then we do not need to write this electron number here. SO2 3 and 6 H2O is changed into the 3 SO4 2 minus plus 12 H plus plus 2 Cr3 plus and plus 7 H2, 2 Cr3 plus and 7 H2O. So these are the species after that are we obtain after making addition. Comet H plus, we check it once more time because any mistake may cause the mistake of the balance equation. Dichromate plus H plus, and next sulfur dioxide is 3 6 H2O, and 3 sulfate 12 H plus, then 2 chromium 3 plus and 7 H2O. So our equation is right now balanced ionic by balanced equation by ion electron method. We get our main balanced equation here. Look at this equation that is formed after adding this two equation, reduction equation and the oxidation equation. This equation is a balanced equation, so we can make this balanced equation in more simpler form by eliminating the common ions that are present in both the sides of the equation. See here it is 14H plus, and here we are seeing 12H plus, so net cancelled, 12H plus cancel, and this one, after cancelling the common ion, we are writing this equation Cr2O7 2 minus plus only 2H plus is remain in the left hand side, because out of the 12H plus and 14H plus, only 2H plus is remaining in this side, and sulfur dioxide will be the 3 SO2 sulfur dioxide, and for the case of water, see here it is 6 H2O and it is 7 H2O, so this one totally get cancelled and 1 H2O will be remain in the right hand side. So we write the 1 H2O in the right hand side, and therefore the chromium 2 chromium 3 plus ion in the right hand side it is not common ion, and sulfate 3, it is not common also. So therefore we write this ions. After cancelling the common ions from both the sides, we get this equation. This is the ionic equation, main main equation for ion electron method, balancing in acidic medium. This is the answer. This is the answer of the balancing. Dichromate ion plus H plus 2 and SO2 3 to H2O to chromium ion and 3 SO 4 2 minus ion. So this is our main equation that we get after balancing a redox reaction that was given to us. So this equation is a balanced equation, and you can write also in molecular form. Like initially we are taking in molecular form, so we write it in molecular form: K2Cr2O7 plus H2SO4 plus 3SO2 to H2O plus Cr2SO4 whole 3 and plus K2SO4. So this one will be in the molecular form, and this one is in the ionic form. So any one can be considered as the balanced equation. Either this one, potassium dichromate H2SO4 and 3SO2 to H2O Cr2 SO4 whole 3 and K2SO. So this is the process of balancing a redox reaction by ion electron method in acidic medium. This is the total process that is need to practice, that is required for balancing this type of redox reaction. I discussed the full topic. I think you like this topic and you understand this whole process that I clearly discussed here. So thank you for watching this video, and if you find that my videos are useful to you, then you can subscribe this channel. And if you find that this video is this video is helping you to any way you're improving your skill, then you can like this video.